This is probably the hardest question in SAT, and I find very smart students fail to solve this correctly. The question is solve for x, where 2 to the power x is equal to x to the power of 32. Now, we can solve this problem in two ways, and let's see what are the outcomes and what results confuse us of those outcomes. Let's start. If we have 2 to the power x is equal to x to the power 32, we can write 2 to the power 1 by 32 is equal to x to the power 1 by x. From here, we can write this 2 can be written as 2 to the power of 2 by 2 whole to the power of 1 by 32. And let me write x to the power of 1 by x as it is. Okay, let me do one thing. Let me write this x to the power of 1 by x on left hand side, x to the power of 1 by x equal to, now this becomes 2 to the power of 2 becomes 4, and 4 to the power half, that I am going to multiply it with 1 by 32. So this will become 1 by 64. So x to the power 1 by x is equal to, now 4 to the power 4, I can write it as 4 to the power 1, I can write it as 4 to the power 2 by 2, 1 by 64. So that will give me x to the power of 1 by x, and 4 to the power of 2 is 16. And this 1 by 2 which is left here, I'm going to multiply it with 1 by 64. So I'm going to get 128. Okay, let us further do it. X to the power of 1 by x equal to 16. I can write 16 to the power of 2 by 2 whole to the power of 1 by 128. And that will give us x to the power of 1 by x equal to, now 16 to the power of 2 is 256. 256, and this 2 I'm going to multiply it with 1 by 28. So I'm going to get 256. So I can compare, I can very easily write x is equal to 256. But the story doesn't end here. If you write value of x is 256, then you are giving an incomplete answer. So what's the complete answer? Let's move on to Desmos and see what answers do we get from there. In that case, what we are going to do, we're going to write this one. We're going to write this one as y equal to 2 to the power x, and this one is also equal to y equal to x to the power of 32. Let us plug in these two numbers and see what answers do we get from there. So here in Desmos, let's write down those equations. First equation is y equal to 2 to the power of x. The second equation, y equal to x to the power of 32. Now what do we see? We see there are two intersecting points, this one and this one. So this first intersecting point, the x coordinate is minus negative 0.97902, 97902, and the other one is 1.02239. So x also has value as 1.02239. So which of these two answers are correct? Is x 256? Is x negative of 0.97902, or x is 1.02239? In fact, for this equation, we have three real values. The first one is 256. The second one is negative of 0.97902. The third one is 1.02239. But why is it so? If you look carefully, we see that this one is an exponential function and this one is a polynomial function. Now, eventually, this exponential function will definitely go and meet this polynomial function. And the point at which this intersection will occur, at that point as x is equal to 256. but it is beyond the scope of Desmos to show that intersecting point. So, one value has to be found out in traditional method and the two other values which can easily be found out using Desmos. Now, be very careful when such type of question is given because always remember most probably that's a trap and you will most of the cases you will only write one of these answers. But remember there will be three intersecting points and here in this case, we have x is equal to 256, x is equal to negative of 0.97902, and x equal to 1.02239.